Here's problem 5.5. An object of unknown weight is suspended as shown. The tension in rope 1 is 25 pounds, and the tension in rope 2 is 31 pounds. What is the weight of the suspended object? So in the British system, a unit of force is the pounds. As we're looking at this, let's identify a free body diagram of the knot. We have tension 1 pulling this way, and that is, as we say, 25 pounds. And then we have tension 2 pulling up this way at some unknown angle, and that is 31 pounds. So this angle over here is 37 degrees. This angle is unknown. Let's call it theta. And then we have tension 3 pulling down like this on the knot. And we don't know what that tension is. Alright, if I were to break these up into components, these tensions, I'd have a T1 cosine 37 degrees going this way, and a T1 sine 37 degrees going up. And then if I were to break up T2 into components, I would have a T2 cosine theta going to the right, and then a T2 sine theta going up. I don't know what theta is. It's a little busy. Let's make a new free body diagram that corresponds to x and y totally. So I'm going to have two components that are going up. I'm going to have a T2 sine theta going up like this, and a T1 sine 37 degrees also going up. Going down, I'm going to have all of T3. Going to the right, I'm going to have a T2 cosine theta, and going to the left, I'm going to have a T1 cosine 37 degrees. As a result of all these forces, I have no acceleration. So that is my free body diagram of the knot where these three chords come together. I want to use this free body diagram to help me set up my equations. First of all, I can say that on the knot, the summation of all the forces in the x direction should be equal to 0. Well, I do have forces. I got T2 cosine theta, and then opposite that, I have a T1 cosine 37 degrees. So, it should be true that T1 cosine 37 degrees equals T2 cosine theta. Or I could say that the cosine of theta is equal to tension 1 divided by tension 2 cosine 37 degrees. That's going to be equal to 25 pounds divided by 31 pounds cosine of 37 degrees. Pounds cancel out, and so we're going to have, what, 25 divided by 31 times the cosine of 37 is 0.644. So this is equal to 0.644. I want theta. So theta is going to equal the inverse cosine of 0.644. And what is that? 49.9 degrees. Alright, so now I know what theta is. It's 49.9 degrees. Alright, let's look at the y direction. Summation of all the forces in the y direction should be equal to 0 because nothing is accelerating. And we do have forces. We have two forces going up. We have T1 sine 37 degrees plus T2 sine theta, which is now 49.9 degrees, minus tension 3. So in other words, tension 3 is equal to tension 1, 25 pounds, sine 37 degrees, plus tension 2, 31 pounds, sine 49.9 degrees. So this will give us tension 3 in terms of pounds. Let's see. That is 38.76 pounds. 38.76 pounds. We want to find the weight of the suspended object. Now, if we made one more free body diagram, we would look at the object and realize that the weight is being offset by tension 3 pulling up. So, by equilibrium in the y direction, the summation of the forces in the y direction should be equal to 0. That would be tension 3 minus the weight. In other words, the weight will be equal to tension 3, 38.8 pounds, and that would be the weight of the suspended object, 38.8 pounds.